Alright, how's everybody doing today, boys and girls? Welcome to sections 5.5 and 5.6 on using triangle inequalities in 1 and 2 triangles. Now again, don't forget to finish the survey at the end of this lesson for those of you who are my students, with address right there on the screen for you. Now today's joke of the day: why is 6 afraid of 7? You would be too if you knew the answer and what 7 is capable of. Let's go ahead and take a look at our first theorem for this section. Now, this is going to be really super common sense. It says if one side of a triangle is longer than another side, then the angle opposite the longer side is longer than the angle opposite the shorter side. That's it. So let's take a look at our triangles here. We've got two pieces here. We've got a triangle with a side length of 8. And we've got another side that has a length of 5. So it only makes sense that the angle across from the bigger side, which in this case is C, angle C, well, that has to be bigger than angle A. So that's all that theorem says in a nutshell. Now also, the converse of that is true also. So the converse is also true. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. So this only kind of makes sense. The side, in this case, that is opposite angle A of 50 degrees, that side has got to be longer than the side that's 30 degrees. All right, and we're going to play around with this a little bit more when we take a look at the Hinge Theorem, because that's where this is going to apply itself. So our conclusion would just be that side BC is going to be greater than side BA. Now again, that's one way that you could write each one of these conclusions. You could switch it around, each one of them, and you could say the measure of angle A is actually less than the measure of angle C. You could write it like that, or you could say segment AB is less than segment BC. So you could write it either of those ways. It doesn't matter as long as you get the inequality correct. We got to list the sides of triangle ARST in order from shortest to longest. Now, this is where you really have to take your time and read, because they're asking to go from shortest to longest. Now, the shortest side, so sometimes they'll give you all three angles, which they do in this case. Other times they'll only give you two of them, in which case you'll have to find the missing angle. But in this case, we have all three, so we can make our conclusions accordingly. The shortest side is across from the smallest angle. So I need to look at my angles, and right here, 29 is going to be my smallest angle, which means that side opposite it, side ST, is going to be my smallest side. I look at the other two angles, and I need to analyze them, and 121 is larger, so that's going to be my largest side. And then the remaining angle, which is just 30 degrees, I like to call that one just medium. So if we kind of think about it that way, we've got a small, medium, and large. So my medium side is going to be this one over here, this side RS, or side SR. So when I go to answer this problem, the thing that you really want to be careful of is to make sure that you read the question correctly. We want to go from smallest to longest. So when I go ahead and write those side lengths down, I want to make sure that I do that in the correct order. So when you write them in order, just make sure that you go from shortest to longest. So ST is going to be my smallest side, and RT is going to be my largest side, and they're going to be in the middle of those two is going to be the length of side SR. Now again, it doesn't matter if you write SR or RS, either way, that's talking about the same segment. So just make sure that you take your time and read this question correctly. Alright, let's take a look at example number 2. Here we're asked to list the angles of triangle ABC in order from least to greatest. The smallest angle is across from the shortest side, and the largest angle is across from the longest side. Now what I like to do here is just go ahead and write down an S for small, an M for medium, and then an L for large next to the three side lengths, so those three pieces. Then what I do is I just draw arrows to the angles that those are representative of. So the smallest side is going to go over here, and that's going to be paired up with angle A, and then my medium side, that one's going to get paired up over here with angle C. So once I've got all of those set, then it's really easy for me to organize from smallest to largest. I just have to make sure I take my time and get my order correct. So go ahead, hit pause, and write down the angles in the correct order. So how did you do? Did you get the order correct? Measure of angle A is less than the measure of angle C, which is less than the measure of angle B, is the correct order of the angles in triangle ABC from least to greatest. Not too bad, pretty straightforward stuff. Now let's take a look at this triangle inequality theorem, which in and of itself says a lot, but really it's going to be some common sense here once we start playing around with some numbers. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So any two sides added up together have to be more than the length of the third side. So it doesn't matter which order that you pick, the two sides and the other side has got to be smaller than their sum. So we're going to play with this idea and just kind of develop it here momentarily. Now, there's going to be 3 steps to doing this. Now, the first thing that you're going to want to do is take the two side lengths that you're given. So say we're given the number 4 for one side length, and say we're given 7 for the other side length. So the difference of those two, so I want to do 7 minus 4, and that just gives me 3. Then the second thing I'm going to do is find the sum of those two sides. So 4 plus 7, if I add those together, I get 11. Now that means the length, the possible side lengths, are going to be between 3 and 11. So the third thing that I do is I'm going to write that inequality. So 3 is going to be less than x if x just represents our side length. So our side length has to be between 3 and 11, and that's how you would write that. So in words, we would just simply write the length of the third side is between 3 and 11. Now make sure you write all that down in your notes because you're going to have to do several like this momentarily. Now let me give you a few other ones to play around with and see if you can correctly write the inequalities. Here's 2 other examples with side lengths of 8 and 12 and then 9 and 3. See if you can find the sum and the difference of those two sides and write the inequality in the ensuing sentence accordingly. Once you're done, come on back and see how you did. For now, just go ahead and hit pause. So how did you do with that? Hopefully you got both of those correct. Now make sure you pay attention to the way that it's written in both symbolic form as well as in sentence form. Now with that said, I think you're ready to go ahead and handle example number 3. Alright, so for example number 3, we've got a triangle that's got one side length of 8 and another of length 12. Describe the possible lengths of the third side. Write your solution as a sentence and as an inequality if x represents the length of the missing side. Now I think you guys can probably do this one on your own now, so go ahead and hit pause, and then when you're ready, come on back and see if you got everything set up and written down correctly. Alright, good luck. Hit pause and let's see how you did afterwards. So how'd you do with this one? Hopefully you were able to add and subtract correctly and come up with the two values 4 and 20, and that you were able to correctly write the sentence, the length of the third side is between 4 and 20, as well as the inequality, 4 is less than x is less than 20. Those are the 2 ways to represent the solution to this problem. Now let's take a look at another problem, and I want to just test your understanding, make sure that you're solid and that you got this. So this probably isn't on your note sheet, but you can probably do this one mentally really quickly in your head. So here we go. Which could be the length of the third side of a triangle if one side is 8 and the other side is 15? How do you think you do this one? Same ways you do the other ones. Just take your time, make sure you add and subtract correctly. So 15 minus 8, that gives me 7. 15 plus 8, well, that gives me 23. So I can pick any number between 7 and 23. Now, 4 is not in that range, so that one's gone. 7, even though that's right here as one of the possibilities, my third side has to be between 7 and 23. It can't be 7 or 23, so that one's gone. Now, for choice C, 12 is in between 7 and 23, and 32, well, that's just too big. That's outside of that range. So the correct answer is C, 12. Now let's move ahead and check out our next example. Now before we get into actually describing the Hinge Theorem and the converse of the Hinge Theorem, let's kind of think about it like this. Anytime you open a door, you're going to have it open only a little bit, or you can open up that door a lot. But there's going to be 2 things that will not change. Do you know what those things are? Let's take a look at these pictures below. Study them carefully and see if you can identify 2 things that don't change. One of them is definitely going to be this piece right here, the door opening. That spot right there and that spot right there. Both of those are going to be the same no matter what. Now the other piece that's going to be the same is going to be the length of the door itself. Like however long that door is there and whether we open it up there, both of those, that length isn't going to change no matter how open the door is. The piece that will change is just going to be the angle that the door is open. Whether it's open a little bit, like the picture on the left, or if it's open a lot, like the picture on the right. Let's think about this just kind of in common sense terms too. And I'm going to ask you this question. I don't mean to insult your intelligence, but it's basically what Hinge Theorem or Converse says. Which one of these pieces would be bigger? This length right here with the door on the left, or this one over here with the door on the right? Well, I'm sure that you're able to figure out which one of those is bigger. And so what we're going to take a look at is not just which side is bigger, but also which angle would end up being bigger. So that's going to be the crux of the Hinge theorem and the converse of the Hinge theorem. So we're going to go ahead and formalize that a little bit when we take a look at it like this in a moment. When you open the door, we can definitely see the smaller opening and the larger opening. So the smaller opening is going to have a shorter distance. It only makes sense that the larger opening is going to have a longer distance. Pretty straightforward stuff. Very, very common sense. So don't overthink it, even though we get into some technical jargony stuff. So let's take a look at that technical jargony stuff here. Alright, so here we go with the Hinge theorem. The Hinge theorem states, if two sides of one triangle are congruent to two sides of another triangle, then the included angle of the first is larger than the included angle of the second. Then the third side of the first is longer than the third side of the second. Wow, that's a lot of stuff just to say, hey, this side over here is going to be bigger than the side that's over here, because 88 is a bigger angle than 35. So that means XW or WX, either way you want to write it, is going to have to be bigger than the ST part, or TS, either way you want to write that. That's all that says. Pretty straightforward stuff. Now the converse of the Hinge theorem says, all right, we're going to take a look at the sides first, and based on the sides, then we're going to make a conclusion about the angles. So if two sides of one triangle are congruent to two sides of another triangle, then the third side of the first is longer than the third side of the second. Then the included angle of the first is larger than the included angle of the second. All right, so here we've got one side length of 12 and another side length of 9. The other two sides are both congruent. So what I'm looking at is the angles opposite. Angle C here and angle F there. Well, which angle is going to be bigger, angle C or angle F? If you're thinking angle C, you are correct. So the measure of angle C is going to be bigger than the measure of angle F, because 12 is bigger than 9. Alright, that's all there is to that. Don't overthink it and make it more complicated. Keep it simple. Now, we're going to take a look at example 4 here, using this diagram at the right, explain how you know for each. Now, check this out, pretty straightforward. PR equals PS, and we can see that because it's marked on the diagram. And the measure of angle QPR is bigger, so this is our greater one, than the measure of angle QPS, which is longer, SQ or RQ. So all we have to do when we look at our diagram is be sure we note which one is our bigger angle. Since angle QPR is our greater angle, that one's bigger, then that means side QR is going to be our bigger side. So since QPR is the larger angle, that means side RQ or QR, either way you want to name it, that's going to be the bigger side. And that's all there is to it. Again, simple stuff, don't make it complicated. Alright, now let's take a look at part B. If PR equals PS and RQ is less than SQ, which is larger, angle RPQ or angle SPQ. And again, SQ is my larger side, my longer side, so that means that the angle across from that is going to be the larger angle. In this case, angle SPQ. You could call it angle QPS. Either way, we're talking about the same thing, but since in our question they give it as angle SPQ, that's how we would name it. Pretty straightforward information. hopefully you're able to hang in with this, and it's just pretty much common sense for you. Again, don't overthink it and make it more complicated. Now, speaking of complicated, this is where it will get complicated. We have to write and solve an inequality to describe the restriction on the value of x. So what I want you to do is make sure you mark a diagram. Anytime you see this, we'll go ahead and mark this, because we've got these two pieces here that are both 12. So that side and that side are going to be congruent. And of course the side they share, that's going to be congruent to itself. So those are the two sides right there. Now, common sense, but again, I want to take a look at our two possibilities. We've got the angles 45 and 115. Now, which one of those is the bigger angle? That's right. If you picked 115 degrees, you were correct. So what I want to do then is compare the sides next. So the side across from the 115 is going to have to be bigger than the side across from the 45 degrees. Now you've got two ways that you can set that up to solve it. And that's all you are going to need to do. Make sure you get the setup right. And once you have the setup right, then the rest of it is going to be pretty straightforward arithmetic. Now you can solve it either one of two ways. You can set it up like the part on the left, the inequality on the left-hand side, or you can solve it like the inequality on the right-hand side. Either way, whichever way makes more sense for you, is the way that you can go ahead and set it up. The only thing you're going to have to make sure that you do is make sure your arithmetic is correct and you don't make any careless mistakes. When you're all done, you'll get the restriction that x has to be greater than 1 or 1 is less than x, depending on which way you set it up. Now, here we go, wrapping up our joke of the day. Why is 6 afraid of 7? That's right, because 7, 8, 9. Ooh, watch out for 7. He's a hungry little bugger. Now, don't forget to complete the survey at the end, because that is going to be built into your assessment for this chapter. Make sure you get that done and any of the other ones that you need to finish up. All right, thanks for watching. I'll talk to you guys soon in class. Peace out.